Hello friends, welcome to the channel All Competitions. Under this channel, we are going to start the lecture series related to the automata theory or theory of computation. This course is introduced in second year BTech of Computer Science and Engineering. So, in today's lecture, we are going to see which are the basic terminologies related to the theory of computation or automata theory, that is alphabets, strings and languages. So let us see here what is meant by alphabet. So as we know that the natural language like English or programming language like C language, C++, Java or any type of programming language, it requires some alphabets for constructions. So in the case of alphabets, let us see English language. So if you go for the English language, you can see A, B, C up to small z. These are the lowercase letters, as well as we are using A, B, C up to capital Z as a uppercase letter, as well as we are using punctuation mark, white spaces or blank spaces for constructing the English language. Means unless and until we are using these alphabets, it is not possible to construct the strings or the words or the language, that is the English language. So that is the necessity of the English language. Means unless and until we having these alphabets, we cannot go for the construction of word or sentence in the English language. So let us see here one string, India. So India is the string which is made up of the alphabet from the English language. You can see here this I, that is a lowercase NDIA. So totally the length of this, so you can see length of this India, which is equals to 5. So that is the notation for finding the length. So India having length as a 5. Another word, let us say call. So in the case of call, I can write here the length of call, which is equals to 4. Okay, and the alphabets, generally the alphabets are denoted by notation. You can write here notation for alphabet, which is a sigma. Sigma is the notation for alphabet, means all the alphabets are covered under the sigma, or language is covered under the sigma. Okay, it is a sigma as well as it is called as a summation. So let us see in the regular language. In the regular language, you can see summation is the set of alphabets. I am taking here two alphabets for the discussion, 0 and 1. So 0 and 1, these are the two alphabets for the discussion I am taking here. And generally in the case of regular language, we are going to deal with 0, 1. Sometimes it will be deals with the single alphabet 0. Sometimes it will be deals with the single alphabet 1. Or depend on, maybe sometimes it may be A comma B, or depend on the string you want to use, or depend on language you want to use. But remember that unless and until we having these alphabets, we are not able to construct any type of language. So you can be right here what is meant by string. So string is nothing but collection of some alphabets. It is nothing but collection of some alphabets. So if I go for this 0 and 1, so possible strings are 0 may be there, means length of this 0 will be equals to 1. Then I will go for 1, again this 1 having the length as a 1. Then I can be go for 0 0, which is nothing but having length 2. I can be go for 0 1, which having length as a 2. Then 1 0 is there. In the case of 1 0, which having length as a again 2. Then one is there which having length as a 2, and so on. I can go up to the infinity. Okay, so let us see here. So means all these are possible strings. So as I mentioned here, sigma is the set of alphabets, and I have taken here sigma is equals to 0 and 1. Okay, by using that 0 and 1, I can go for various strings. As I mentioned earlier, that is a string with the length 1, string with the length 2, and so on. I can go for string with the infinite size. Okay, so what is meant by language? So see here what is meant by language. So language over the alphabet or language over the sigma is nothing but sigma star, or it is also called as a sigma clean. Okay, and which containing all the possible string which is made up of 0 and 1. So possibilities are null. So what is the meaning of this null? Nothing is there. Okay, that is a size which is equals to 0. You can go for 0, 1, 0, 0, 1, 0, 1, 1, then 0, 1, 1, 1, 1, and so on up to the infinity. So all these are possible strings with respect to the alphabets 0 and 1. And what is meant by language? The language is nothing but collection of all the possible strings with respect to the alphabet. Okay, I hope that you are getting this. Now let us see string and substrings. Okay, so let us take here some examples. W1, W2, man, common, wealth. Okay, so now see here, if you see the three strings W1, W2 and W3, you can say that all the alphabets in the string W1, that is a M, A and N, and by using that M, A, N, this string is formed. Means all the alphabets with the same sequence are present over here. You can see M, A, N. Yes, also M, A, N is present over here. So you can say that W1 is substring of both W2 and W3. I hope that there is no doubt. W1 is substring of both W2 and W3. Then while talking about W2, so in the case of W2, we having 5 alphabets COMAN, and in the case of W1, we having only 3 alphabets. Means it is not possible to show that W2 is a substring of W1.